A particle moves along the x-axis so that its velocity v at any time t for the interval from 0 to 16 is given by v of t equals e to the 2 sine of t power minus 1. At time t equals 0, the particle is at the origin. Part A. On the axes provided, sketch the graph of v of t for the interval from 0 to 16. The easiest way to do this is to make a table of values and to plot points so that you can sketch the graph. You can get these points by either plugging them into your calculator or by solving them in by hand. Once you have enough points to sketch the graph, you go back to the graph and you start plotting the points. Once you have plotted all the points, you can sketch the graph based off of the points. Part B. During what intervals of time is the particle moving to the left? Give a reason for your answer. The particle would be moving to the left when the velocity of the particle is negative. So you set up an equation based on that. The velocity of the particle would have to be less than 0. Then you plug back into your equation and you get e 2 sine of t minus 1 is less than 0. You then solve the equation to find where the points where it's moving negative. Now at this point you can make it equal to 1 so that you can solve for the critical points, then find when it would be negative. So to solve this, you can take ln of both sides to cancel out the e. You are left with 2 sine t equals 0, since the ln of 1 is 0. When you divide by 2, you're still left with sine of t equals 0. So now you have to find all the times where sine of a number is 0 on these in the domain. And this occurs at pi, 2 pi, 3 pi, 4 pi, and 5 pi. Once you have all of these, you can make a sign chart, or you can refer back to your graph to see in which of these intervals it is below the x-axis. For the sign chart, it would look something like this. Another thing to remember when you're doing this is that you have to check the endpoints, because it can be equal to 0 or equal to 16 as well. Now that you have your sign chart, you can fill it in to find out where it is negative. When you plug in a point between 0 and pi, you get a number that is positive. Then you get negative, positive, negative, positive, negative. This shows you that the velocity is negative in the intervals pi to 2 pi, 3 pi to 4 pi, and 5 pi to 16. The only number that would have a bracket around it would be the 16, because at pi, 2 pi, 3 pi, 4 pi, and 5 pi, the velocity is 0, and so that's not less than 0. Part C. Find the total distance traveled by the particle from t equals 0 to t equals 4. To find the total distance, when you have the equation for velocity, you need to set up an integral. The limits of the integral will be 0 and 4, as indicated in the question. For inside the integral, you need to remember that it has to be the absolute value of the velocity because it's asking for the total distance. If it was asking for the displacement, you would just do the velocity equation on the inside. But since it's total distance, you need to count all the negative area it traveled as well as the positive area. When you get to this point, it is usually best to just plug it into your calculator and solve, because you're allowed a calculator in this part. When you plug it in, you get 10.542. Part D. Is there any time t in the interval from 0 to 16 at which the particle returns to the origin? Justify your answer. Now, to figure out whether it ever returns to the origin, the easiest way to do this without justifying it at this point is to look back at your graph, which I'll sketch one more time back here. Now, the negative area that this graph accumulates, marked in orange, never is equal to or exceeds the amount of positive area accumulated that is marked in green. This shows you that no matter how far along the 16 interval you go, it never returns to the origin because the negative area is never equal to or greater than the positive area accumulated. So now that you know that the answer is no, you need to prove it to the AP readers that you understand why it is no. The easiest way to do this is to write an integral. From the limits would be 0 to t being in the interval from 0 to 16, of the velocity of the particle. This time the velocity is not an absolute value because it is asking for the displacement and not the distance traveled. So you want to show that this is always greater than 0. 0 would be the displacement that it would have at the origin. And this would be a true statement, but you have to add for all t is greater than 0, because this shows that you understand that in that whole interval it never returns back to the origin